Hi, this is Erik with Technically Speaking at Source Allies, and today we're going to be talking about getting started with gRPC. So if you're not familiar, gRPC is simply a different way of doing remote procedure calls. So if you've been in web development for a while, you're probably familiar with making REST API requests, and those usually are using JSON. Or if you're unlucky, you might have worked with SOAP and XML. Those are both ways of doing remote procedure calls. gRPC is just yet another way to do that. So why would you want to use gRPC? Well, the main draw of gRPC, well, there's two. The first being that you can generate both your client and your server code. So if you've used GraphQL before, you might be familiar with code generation. Apollo GraphQL is very popular, and they let you generate both your clients and, in some cases, your servers. I think you have to use Apollo Server for that, but it'll let you generate a lot of your code. So you get type safety when you have your requests. So gRPC brings that to just about everything else that's not GraphQL. In addition to that, the other main draw is that the transport serialization method is protobuf by default. So protobuf is similar to other binary encoding formats. It's just a different way of doing it. But the nice thing about protobuf is that you can define your services and your messages in proto files. And from there, that's how you generate both your client and your server code. So, got the gRPC website up here. You can go take a look at that if you're interested, grpc.io. Today, to kind of speed things along, I'm going to be using Buff to do a lot of the Proto-C headache stuff, and I think they even share schemas without headaches. So gRPC has been around for a while, and I think that it has struggled to get adopted because it's a little bit painful getting into it. Once you're into it, it's really easy and awesome, but there's a lot of setup that you have to go through, and Buff is going to make this super easy for us. In addition, we will be using ASP.NET, and of course Microsoft has to be different, so they have a little bit of special handling for some of the gRPC stuff, but they do have first-class support for it. So with that said, let's start writing some code. To get started, I've got a completely empty directory here. We're going to start by creating some folders in here. So we're going to create an API, and we're going to have an app that will call that API. And from there, we're going to use buff, so we'll do buff config init to generate just a very simple buff config file. You can see it doesn't have too much going on here. It's got some defaults for linting and breaking changes. By the way, another nice thing that gRPC has, I should say buff has. It allows detecting breaking changes as you make modifications to your API, but that's not what I'm going to talk about today. We're going to be putting our proto files into the proto folder, so we'll get that added down here. Let me make sure I got the syntax right on that. Oh, forgot the path. There we go. And it's modules. There we go. All right, so one of the conventions when you're working with gRPC is to share your schema in some way, and the common convention is to put that in the proto directory. So we'll start by creating proto, and then we'll have our service name, and then we will have the version. We need -p if we're going to call it like that. So now we'll have proto hello, which is going to be just sort of our domain or our namespace for this, and then we'll have the version, which we're going to start at v1. This doesn't have to look like this. Buff will kind of guide you in the right direction if your naming conventions don't align with kind of what they're expecting, but all that's configurable in this config file, and you can do whatever you want, but this is the way we're going to do it. So inside of the proto hello v1 folder, we're going to create a protobuf file. So we do hello v1, and then we'll call it hello.proto. And by default, VS Code won't have super great syntax highlighting for this, but Buff has a VS Code extension, so you can install this and get going. If you're using other IDEs, I shouldn't say VS Code's an IDE, but if you're using JetBrains products or Visual Studio, there's also protobuf support in those. You don't have to have VS Code. If you're using Buff, the Writer or the JetBrains IDEs have wonderful support for Buff. There's built-in plugin, there's also a Buff provided one, and then there's also a third-party one by just some guy who I think makes the best plugin. It's like Hegan or something, but great IDE support. So we're going to be using the Buff extension in VS Code for this. So we've got our Buff YAML, and we'll have a proto file here in a second when VS Code decides to refresh. And when we're working on this, we're going to get started by filling out just some boilerplate stuff. So if you've been around protobuf for a while, you know that they kind of changed up the syntax. Well, if you've been around protobuf for a while, you probably aren't watching this, but there is Proto 2 and Proto 3. You should be using Proto 3. There isn't too much of a reason to use Proto 2. So we'll get started here, and Buff is whining at me because we got to have a package. So let's create that package, hello v1, v1. There we go. Now Buff's going to stop about that. So said that we get to define our types in here. So let's define our message types first. So we want a simple remote procedure that's just going to accept a message and return back what you said to it. So we'll start by creating our request. So we'll have a message, and we'll just call it say request. And the syntax should look pretty familiar. This has kind of a C-ish style syntax. And the fields on our method, we're going to have a string, which is going to be the message. And when you're working with protobuf, you have to assign the fields numbers, because what this ultimately is doing is it is an encoding format. So in order to make that super efficient, you need to give it a little bit of information to kind of help it on its way. So here we're saying this is the first field. So when protobuf is doing all of its magic, it's going to know that there's going to be a string, and the field is going to be called message, and it's going to be the first one. And these can be anything you like. You can start at any number, within reason. But they need to have numbers. And when you go to add new fields, this is kind of how the breaking changes work. In order to keep your APIs compatible and not breaking across different clients and servers and all that whatnot, when you add new fields, you're going to always increment this. So now that we've used 1 here, this is never going to get used again, because if we were to do that, that might be a breaking change. And again, getting too in the weeds on that stuff, but gRPC has wonderful support for all of this stuff. So we've got a request, so let's create a response as well, and we'll call it say response. And we will also give it a string, and it's just going to be reply. And it'll be the first field in here as well. So we've got our messages. Now we need an actual service. So we define those by creating a service, and we'll just call it hello service. And then we'll have an RPC on it, and that RPC is just simply going to be called say. Familiar with the syntax highlighting? This is kind of the function syntax highlighting. It's not actually a function, but it kind of helps stay in a familiar place. So when we call say, we need to give it our say request, and it will return a say response. And to continue with the C-like syntax, we will end that with semicolon. So thank goodness Buff is happy with our little protobuf file here, and we have no errors. So we've got our service defined. So great, where do we go from here? This is where the fun happens. We get to actually start generating code. So we'll create a buff gen YAML, and we'll put some stuff in here. So the structure that I'm planning for this is we will have a Go server, and we will have a .NET client that will be talking to each other. So we'll start by creating the server. So when we're generating code for Buff, first we need to start with the version. So this will be v2. Should match with your config file. It's not super important. Buff is only on v2. They're still figuring things out. So v2 I think came out a little bit ago. I'm not quite sure, but we're going to be using v2. And they also have this concept of managed mode. So I'm not going to go too much into that, but it is great when you're starting out. So we're going to use that. And because we're writing Go, we're going to provide an option here that just makes our lives a little bit easier. We're going to give it a Go package prefix. And the value of this is going to be the name of our project, which is this project I'm just going to call TS source. And we're going to put it in the service directory. So if you're doing this for yourself, this basically aligns with whatever your Go module is. So that's often github.com, username, repo, something like that. But for today, I'm just going to do TS source, and we'll put it in service. So now on to the meat and potatoes. One of the headaches when working with protobuf files is just managing them. And that's why I was kind of mentioning at the beginning that protobuf has had some growing pains. And I think one of the reasons why it hasn't gotten super well adopted is because it's really a pain getting the Proto-C compiler set up on your machine and all of the CI/CD around that. And that's where Buff comes in and makes things super easy. So if you're doing this without Buff, you would have to download Proto-C. You'd probably have to download any plugins that you want to use. I can't remember what's distributed with Proto-C itself. I don't know if anything is, but you'd have to download the Go Proto-C plugin. You have to download the .NET one, or maybe not. We'll talk about that later. But Buff makes it really nice with the concept of remote plugins. So we simply define our plugin array here, and we'll give it our first value. We can just say remote to indicate that this is referring to a remote plugin. And they host those themselves, so those will be hosted on buff.build. And since we're using Go, we'll do gRPC Go, and the version that I've got for that is v1.4.0. And now we want to say that we're going to put it in API, which matches our folder name over here, and then service, which is what we said we were going to put it in over here. So we've got that. We'll also define an option. These are options that get passed to Proto-C. So for this is just a little, if you're getting started, you should probably have this. When you're actually developing your application, make sure to pick the options that work for you. So we're just going to say that paths are source relative. And then to kind of elaborate on some of the concepts here. So I mentioned that Protobuf allows you to encode your messages, and that's kind of a wire format. So that is separate from gRPC, which is the actual sort of service implementation that we're going to be building on. So when we go to generate code, we actually have two things to generate. We have to generate our protobuf types, and then we also have to generate the services as well. So right here, you can see we're using gRPC. This will be our service definitions. So we also need to generate our protobuf types as well, and we'll do that with another remote plugin, again hosted on buff.build. These don't have to be hosted there. It's just very convenient. They have a bunch of stuff out of the box. These can be hosted wherever if you want to host your own plugins. I'm pretty sure that will work. Don't quote me on that. But we'll want to be using protocol buffers, and we're generating for Go, and we'll be using version 1.34.2 just because that's what I have. And it's got the same secondary options. We want to put it in API and service, and we'll give it the same option here because this is still Go code. So there we go. So now we've got our buff code gen file defined, and to work with that, we'll run buff generate, and this should, must have had a typo somewhere. Haley told me I was supposed to leave these in. It's plural, protocol buffers. There we go. See, leave my mistakes in and things work out. Okay, so over here you can see that it's generated some code for us. Isn't that super awesome? First off, you'll notice that we have API and service, which is where we told it to put the code. And then we also have hello in v1. And that's sort of inferred from your directory layout with the proto files. Within this, we have two files defined. So I mentioned that we have two things to worry about. We have the actual protobuf messages, and then we have the services themselves. So this first hello pb go is our protobuf definitions. So within here, we'll see the definitions for our message types. So we have our say request, and we have our say response. And there's a whole bunch of stuff in here that you'll never have to worry about. This is just sort of instrumentation for gRPC and protobuf to do their thing. Looking at the other file, we can see this one's labeled gRPC. So this is going to define our actual services and clients. So you see it's generated this hello service server. The names are fun. You can change that. And we also have some other things going on here. So we have like this unsafe, blah, blah, must embed. We'll talk about that in a second. And then we have our register method. So you can see that gRPC has done a heck of a lot for us here. And I guess more specifically, protobuf. So it will get all the way to the point where we are registering our service with the server, right? It's helpers and stuff to do all of that. So let's get some of these errors to go away. So we'll go into the API, we'll do go mod init, and I think I called this TS source this time around. So we'll generate our go mod, and we'll do a go mod tidy. There we go. And things should hopefully be looking a little bit happier over here. Awesome. Now let's go define our service itself. So within service, we'll create a new file and we'll just call it service, actually let's call it hello.go. How about that? And then we'll create our package and we will create our service type. So we'll call it hello service. This will be a struct. And as I was kind of alluding to before, we have to embed the unimplemented service. So I believe what it creates by default, hello v1 is our little package name. And we'll embed the unimplemented hello service server in here. And that just wires up some backwards compatibility, whatnot. Doesn't make a huge difference, just have to do it. And then we'll actually define the RPC itself. So we can take a look at what it's expecting over here. If we go and we find say, wherever that is, there we go. So, and this is the client. Let's go look at the server. Server is what we actually care about. Hello service server. There we go. So the function that is generated for us is very similar to our protobuf file. Go likes context, so we get a context here. And then we have our say request and our say response. So we'll take this, we'll pull that out, we'll go over to our service file, and we will implement that. There we go, and we need to prefix these because they're from a different package. And you don't have to do this, but a nice little convention is just to rename this to PB. Shorter. Go really likes its short names, so we'll stay within those bounds and we'll use a short name for our import here. Inside our service, we can do whatever we want. This is where you get to have your fun and write your application. For the demo, I'm just going to be returning back what we got. So we're going to return a say response, and the reply is going to be sprintf, and we'll just say you said blah. And we can go over here, and we got to give these names. So we'll say request and ctx. Again, Go loves its short names. And we'll do request.message. There we go. And we got to return two things because errors. So we'll just do nil for the error. And, well, there we go. There's our service. So we've done it. Let's go wire it up. So we want to have a main.go file. Main.go, package main, func main, and to create our server, so the first thing we'll want to do is we'll create grpc.newServer. We go. We can give it some options. We'll just leave it empty for now. And then we want to register our service that we just created. So we need to tell gRPC about the custom stuff that we wrote. So we'll do register hello service, and it wants the server. There we go. And then we will give it our implementation. So we called this service.helloService, and it doesn't have anything else. So this is formatted kind of funky. Haley makes me turn up the font size really high. So let's just put all that on screen. And once we have that, we need to create a new listener. So I believe that is what net.listen, and then we have to give it TCP4. So we'll be listening on TCP, and this doesn't have to be 4. We can just do TCP. For the sake of demos, I want to keep things consistent and do TCP4. Words are hard. And then we'll give it the address that we want to listen on. So we'll just listen on 000 port 4200. There we go. And this returns an error. Yep. So we'll pull the error out of there, and we'll just do the simple thing. If error is not equal nil, panic error. Boom. There we go. Now we should be able to do server.serve, and we'll give it the listener. And just to have a little bit of niceness here, we'll print out what we're listening on. So we'll just say listening on 000 4200. There we go. And if we do go run main.go, we should see we're listening on 4200. There we go. So we'll stop that for now, and we'll go work on our client. So we'll go into app, and we'll just create a new .NET new console, and I'll steal the name that I used when I was practicing this, and we will put it here because Microsoft loves to create too many folders. So we'll just use our app folder. And when you're just generating a console app, it doesn't put a whole lot of stuff in here. Basically, you get your project file and you get your program file. So I have the .NET 9 SDK installed. Let's keep things modern, and we'll do .NET 8 for support reasons. And I think syntax highlighting is a little bit wonky here. Let's close out of stuff. Did run a build, so we know that's working. When we're developing in .NET, all you got to do is add a simple package, and we'll use the the terminal for this. So we can do .NET add package gRPC.ASP.NET Core. And this is a meta package. If you're familiar with .NET, they like to have meta packages as well, especially ASP.NET. So this is a meta package that contains like 3 other packages. Let's see, I made modifications and forgot to save. So let's just exit out of there. There we go. This is a meta package that contains like 2 or 3 other ones. ASP.NET went through a whole big package renaming thing. It was like from gRPC.core to something else, and they created a whole new repo. That's not important. What is important is that we need the gRPC.ASP.NET Core package. And once we have that, we need to tell it about our protobuf file. So we'll create a new item group block here, close that out, and we'll have a protobuf block. So gRPC.ASP.NET Core has pretty good MS Build support. So they have a custom MS Build item called protobuf, and this accepts the standard include. If you've ever worked with MS Build, you write includes all over the place. Hey, there's another one right there. We want to give it the path to our protobuf file. So we have to go a directory up and then into proto, hello, v1, and hello.proto. And over here, we want to tell it what type of service we want. So we can generate both clients and servers, and you can tell it both if that's what you want. For this sample, I'm just going to be using clients, so we'll just say client over here. And if we do a .NET build, this should still be working, hopefully. There we go. And if you're familiar with .NET source generators, there's lots of stuff you can be familiar with. This leans on source generators for the code gen. So the Go code we put in a directory. ASP.NET will do that for us. And if you want sort of a sneak peek as to what it's generating, you can take a look in the obj debug and then your framework version folder, and you can see that it generated some code for us. So here we have our hello service. So here are the service definitions, and then over in hello CS, you can see here's some more gRPC stuff. So this is in the obj folder. You've never had to touch that before. You still won't have to touch that. But if you want to peek under the hood, that's where all that stuff lives. So we'll go and we'll actually use our service. So in .NET, we first need to create a channel. So we'll do var channel equals new, oh, not new, and let's also spell right, equals gRPC channel. Oops. And we'll give VS Code a little bit to catch up, but for address is what we want. And if we can get VS Code to be happy with our project here, .NET restart language server. Oh, still not happy. Oh well. Yeah, we'll figure that out later. There's a whole big topic in gRPC around TLS. So gRPC is built on HTTP 2, which has the addition of trailers, in addition to some other things that are improvements on HTTP 1. But gRPC requires some of that stuff to work properly. In addition, some of the communication happens over TLS. So gRPC is actually requires TLS. It's not a hard requirement. We can work around it. You can do insecure connections and things will work fine. But your life will be a lot nicer if you have TLS set up and configured properly. It will work for our purposes with just HTTP, so we'll stick with that for now. And we will call our service on localhost 4200. So once we have our channel, then we need to create a client. And this is going to be our generated client. So we'll have a new hello service dot client, I think it's like base or something. IntelliSense would be really awesome here. I'm missing a semicolon. I am. There we go. Let's see if this code even compile. Well, it's not going to because we need a channel over here. Let's see how far we can get with this. Yeah, gRPC channel. Yep. Gotta have a namespace import. Let me take a break and come right back, and Haley will make this look really pretty and awesome. All right, end magical awesome transition. We now have errors in our code here. And I am a helpless developer that needs IntelliSense to develop, so we'll just use IntelliSense to figure out the import for me. And what I was forgetting was the .client at the end. So gRPC channel is within the grpc.net.client namespace. And then we'll need import for our service as well. And the generated code, by default, will put that into hello v1. It's a little aside. You can also define options in your protobuf file, and there's like C# namespace or something, and you can give it some other value. Not going to go too in-depth into that. And let's fix this over here, and that's what it was, hello service client. So if you don't like partial classes, too bad. That's how the ASP.NET CodeGen works. You'll have hello service, and then within that, you'll have your hello service client. And if you're generating your server code from this as well, you would have hello service here. This is all we care about. So now we have our client, and on this client, we have our say method. So we can have say, and I believe top level programs will let us, yeah, there we go. So we'll have our say request, and we'll give it a message of, and I've been writing a lot of Go, I put a colon there. We'll say hi from .NET, and we'll close that out. We'll say var response equals that, and then we'll just print out a response. So console write line response dot reply. There we go. So supposedly, let's give this a build. Supposedly, things should be working. So do a build that succeeds. Now let's split our terminal and get these things started up. So we'll go into API, and we'll go run main.go, listening. And over here, still in the app directory, so we'll do .NET run, and it broke. So let's figure out why that happened and come back. All right. Cue end of magical transition number 2. So back over here, it's very important when you're writing Go code that you actually attach your functions to the proper receivers. So our say function is for the hello service. We need to give that explicitly over here. If you caught that earlier in the video, you get bonus magical internet points. There we go. So let's stop this. Let's give her another go. We're listening again. And second try is the charm. And you can see that we got our response back. So if we want to see this in action, we can add a little bit of a logging line into our service implementation. We'll just do a little thumped.println. You got here. Excuse me, everybody's favorite console log got here. Start that up again, do the client request again. Boom, there we go. You see that our message was logged. All right, we did it. So we've implemented both a client and a server in gRPC. We have generated all of the important code. I talked about protobuf a lot, but we didn't really see any protobuf code. So all of the encoding serialization logic is abstracted away from us, so we don't have to worry about it. JSON, protobuf, XML, you can't use XML, but the fact of the matter is that all of that stuff is taken care of for us. Now you might be saying, oh, well, this is service-to-service communication. That's not super useful to me. I define websites, and they call APIs. Well, luckily for you, gRPC has pretty good browser support. Unfortunately, along with the many other growing pains that gRPC has had, the browser support has been somewhat lacking. But luckily, there's been tons of improvement in that space recently. Buff, the same company that made the CLI that we're using to generate our code here, also makes a service called Connect. and Connect is sort of a parent to gRPC. It is its own protocol, but it supports gRPC, and it also has some of the nicer stuff for the web built in. So if you want to be calling your gRPC service from the browser and you don't want to set up a proxy that does all the JSON transcoding stuff, then you can simply use Connect, and it will have a lot of that stuff handled for you. If you don't want to use Connect, you don't like having the first-party services scattered about your code base, you can also use gRPC Web straight from the gRPC folks themselves. It basically exposes gRPC services as JSON endpoints, very similar to what you're used to if you call REST APIs all day long. If you're in ASP.NET and you're running your servers in ASP.NET, they have first-class support for gRPC Web. It's basically as simple as doing map gRPC service.add gRPC Web, something like that. So it's really easy to get started, especially if you want to use some of the more modern tools that have come about, and you'll never have to worry about writing your clients and servers again. Just get to worry about the business logic. This has been Eric with Technically Speaking at Source Allies. Do you have a topic that you want to see covered? Comment it down below, and check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.